Hey guys, welcome to Units and Dimensions PhD series, and let's start. So today we're gonna solve six PYQ questions along with full complete theory. So let's begin. So first of all, let me start by telling you the fundamental and base quantities, which are there's three, which is time, there's length, and there's mass. So most of the times we use these three quantities to write our dimension formulas. Okay, and so the SI unit for time is seconds, for mass is kilograms, for length is meters. Okay, now let me tell you about some important points, which is plane angle. So plane angle is basically more like this. So it's like a circle, and this is an angle subtended. Let's say this is theta. Of radius r is the circle. So this length L of the arc is L equals r times theta. This is something very important for physics as well as mathematics. It is used in many other chapters, so keep this in mind. Okay, now let's go into dimensions. So dimensions are written in the form of M, A, L, B, and T, C. MLT is the way you write any quantity into its dimensions. So let's say speed, right? Let's say speed, which is also known as velocity, is speed is distance by time, right? So how do you break down and write the dimensional formula? Because sometimes there's questions in like tabular form wherein they ask you to match the columns, wherein the wherein the things are given like speed, time, and all that, and you have to match it to the respective dimensions. So speed equals to distance by time. Now distance is length, which is L. Time is t. So speed becomes L 1t minus 1. So similarly, you guys can do the same thing for other quantities. Now this here is known as dimension power. This is known as dimension power. Of any quantity, the dimension power can be written. Now let's go for acceleration. Acceleration. Acceleration is, as you guys know, meter per second square. So this you all know because you guys must have done kinematics. But you guys don't have to stress if this is your first chapter. Obviously, this is your first chapter, but you guys don't have to stress about learning the dimensional powers because, first of all, this is not that important right now. I'm going to teach you a few rules of dimensions, significant figures, and uh, and some more things. That is what is important for this chapter to memorize. It's not about learning the dimensional formulas because this can be done even after once you're done with the whole syllabus. You guys are anyways going to know the dimensional powers by heart. So meter per second is length t minus 2. Quite easy. Okay, so remember force equals mass into acceleration. Now mass is m, acceleration is this, so it's this. So mass into acceleration was it's this unit. Okay, so this is m1 l1 t minus 2. Now let's go to another important thing, which is frequency. Frequency, I think you guys all must have studied. It's 1 by time period, so t to the power negative 1. So anything like wavelength or distance or displacement, they're all L, right? Power. So power is work done by time. Now one more thing, yeah. Work done equals to energy equals to torque. So torque, work done, and energy all have the same quantity. Now energy can be further broken down into my work done can be broken down into force into displacement, and force was right here, which is m1 l1 t minus 1, sorry, t minus 2, and displacement is l1, so it becomes m1 l2 t minus 2. So here's one conclusion, that is work done dimensional formula equals energy dimensional formula equals torque dimensional formula, which is m1 l2 t minus 2. This is worth remembering, and this can help you solve many questions in physics. Okay, so now what are we gonna solve? So here's some pyqs I'm gonna show you. Okay, now let's go into rules of rules of UND. So the first rule which I want to discuss with you guys is the rule of homogeneity. So this rule states that terms, and this is an application rule. This is very, very important, and many questions can be solved using this thing. So rule 1 and rule 2. So rule 1 is that terms added or subtracted have the same dimension, right? So two terms which are added or subtracted need to have the same dimensions. So this is one, this is very important. Number 2 rule is that LHS dimension equals RHS dimension. If this is, let's say LHS equals RHS, then dimension of LHS equals to the dimension of RHS. Another important rule. This is also worth remembering. Number 3, and then let's solve the question, which is uh, that any in a dimension there is one is nu. So that n is my number. So n is my number and u is my unit. And let's say for a given physical quantity, if n is your number and u1 is my unit in, let's say, some unit and some number, then when I change the unit, the number is going to change. And this one, so u2 changes, therefore n2 also changes, but n1 u1 equals to n2 u2. Now let's do an application question which was asked in JEE Main, I guess 2019 or something. 2019, it's a good question. No, it was in 2021. Okay, let's do this question. It says that the density of a material, the density of a material is 128 kg meter cube. Kg by meter cube, I mean. So this right here is the number n, this right here is the u. This is n1 u1. Now they're saying in certain unit. So in certain units, in certain unit of length. So in certain units of length, it is 25 centimeter and mass is 50 kgs. So density of a material is 128 kg by meter cube in SI unit. Yeah, this is an SI unit. But in certain units of length is 25 and mass is 50. Then the numerical value of density is, right. So now let's see how do you tackle this. So right now I just showed you n1 u1 equals n2 u2. So here these two constitute u2. So when I write down, I say n1, which is 128, and u1. Now what was u1? U1 was kg by meter cube. So kg is 1000 grams. Meter cube is meter cube. 100 to the power 3 centimeter. This is n2, wherein it is 25 centimeter and 50 grams. So 50 gram by 25 centimeter. And the cube of this thing, right? So this is what we have right now, and let's find n2. So this is how you can convert by giving, let's say kg by meter is given, so you can make it into gram by centimeter and so on. So the n2 right now I'm getting is so this thing is 100 into 100, this is 4. So here I can get 1000, so this is gone as well. So 20 by into 128 by 4 into 4 into 4, which is 64. So the answer is n2 equals 40. Right, so our answer is n2 equals 40 numerical value, right? So the n2 u2, but n2 is 40 and u2 is the units, which was 25 centimeter and 50 gram. But this is how you solve it, right? So N2 was to be found, which was the numerical value, and there you go, we found it. So this is how we can use this rule of N1 U1 equals N2 U2 for conversion of one unit to another, wherein the numerical value changes. Another very important rule which I wanted to tell you guys, and there's many questions in JEE about this one, which is, let's say there's ln of something, right? Log n, log base e of ab, right? Ab is two quantities, and so here ln of ab is dimensionless. This thing here is dimensionless, as well as a and into b is also dimensionless. So anything inside ln and the whole ln is, both of them are dimensionless. Dimensionless. So when I say sine of something, let's say sine of a, or let's say cos of a, let's say tan of a, or anything, you guys feeling me, right? So this thing right here is dimensionless. All of this, all the three of these are dimensionless. And a, so wait, let me change this to b and c for clarity. So a, b, c, they are dimensionless as well. So in ln, sine, cos, tan, the inside of them is also dimensionless, and their end result is also dimensionless. Okay, now time for some pyqs. Let's do this one right here. So here, let's use our four rules and solve this question. This was the latest 5th April question, in very easy one. So let's see how do you solve this. So what is the dimensional formula of a by b in the equation p plus a by v square into v minus b equals rt, where letters have their usual meaning? Okay. So as you see, the rule states that while adding or subtracting, the dimensions have to be same. So a by v square equals to p, right? Similarly, v minus v equals to b. So v is volume and p is, and a is pv square. So when I try to find a by b, which is pv square by v, I'm gonna get pressure into volume. Now all you have to do is, volume is length cube, which is because it's meter cube. Pressure equals force by area. Force was mass into acceleration, so m1 l2 t minus 2, and area was l length square, so it becomes m1 t minus 2 l cube. M1 t minus 2 l cube. Uh, I think I messed up somewhere. Okay, don't worry, but it's pressure into volume. That's all. Pressure times volume, right? I think the answer is, yeah, it's this. It's D. L2. Volume is length cube, mass into acceleration. Yeah. Okay, yeah, it's ml squared t minus 2. My bad. Took a lot of time. But yeah, this is how you do it. While adding, the two terms have to be same. While subtracting, they have to be same, and LHS equals RHS. So, okay. Now let's jump to rounding off. Rounding off. The first rule for rounding off is that, let's say if it's 16.35. I know you guys know how to round off, but just in case, because there's been questions on this as well. So 16.35 is obviously 16.4 because 51 is above 50. So therefore it's 16.4. Next comes 3.250. Now because it's 0.50, there's two things that matter. If it's an even number right here, if previous to 5 is an even number, then it stays even, that is, it stays the same number. But if it's an odd number, then it becomes the even number. So if it's 3.250, it becomes 3.2. But if it's 3.35, or let's say 2.35, then the number previous to 5, if it's even, then it stays even. If it's odd, then make it to even the next one. So this becomes 2.4. I hope it's clear. This was just one thing that I wanted to explain about rounding off, because many people get confused in this, and rounding off isn't that easy of a chapter. So this is just one thing I wanted to explain you guys about rounding off. Okay, now let's dig deep into this next thing, which is significant figures, and there's been a lot of questions on this as well. Before that, do you guys want me to, show you guys a pyq? Yeah, let's do this one. This one right here is on the same concept which I explained to you guys about sine and cos having dimensionless quantities. So let's see what it states. It says that the equation of stationary wave. No need to know what stationary wave is. This is a UND question, doesn't matter. So y equals 2a sine something something. So nt, dimensions of n, x, and all of that, right? So the first thing that strikes me is that sine of something is dimensionless, cos of something is dimensionless, so y equals 2a, right? Okay, and sine of this and cos of this, so 2 pi, so basically 2 pi nt by lambda is dimensionless, and so is 2 pi x by lambda dimensionless. So what I mean to say is that n times t has dimensions of lambda by 2 pi. 2 pi is a number, doesn't matter. So lambda is length. Yeah, one more thing. I just explained this here. I told you guys that lambda is length, didn't I? Look right here. Wavelength, which is lambda obviously. Distance, displacement, they're all length. So right here, lambda is length. So we get to know that n times t is length. So this one is not our option because we have to find the incorrect one. This is correct. Let's look at the second statement, which is dimension of n is L by t. Okay. So because nt was L, so n equals L by t, obviously. Come on, bro. Like, even if you guys didn't know how to solve this, you guys can, tackle these two statements and think of how do you eliminate them, because if nt equals L, then n equals L by t. So basically, the two are interrelated to each other. Therefore, it becomes quite obvious that these two are correct, because any one of them is this is a single correct option. So yeah. Okay, so the next one is the dimensions of x is L. So 2 pi x by lambda equals dimensionless. 2 pi doesn't have any dimension, it's a number. So x has dimensions of lambda, right? Which is length. So this is correct as well. But now obviously this is the only one left, so this is incorrect. Let's see how this is incorrect. So n by lambda has dimensions of time. Okay, so nt is lambda and x is lambda as well. So when I do nt by x, oh yeah, this one's wrong, obviously. Okay, let's move on. Let's do this one now. Another pyq right here. So next one, I'm gonna explain you guys sig figs, and then error, and then we're gonna end this one because vernier caliper is in the next video. So go check vernier caliper out. But let's see this one. So, time period of oscillations of the similar pendulums, their times are given as arithmetic mean. Oh my god, how easy can the question get? Okay, okay. So 4.62, 4.632, 4.6, 4.64. So the average is the minimum sig figs is in which you have to report your answer. It cannot be this, cannot be this, cannot be this. So obviously this one is the answer. Okay, and now let's move on to the next one, which is next concept, which is sig figs. Sig figs. It's pretty important, and Yeah, let's see. So there's basically rules to this thing. The first rule is that all non-zero are sig figs. All non-zeros are sig figs. Let it be. Okay, all non-zeros are sig figs. This is the first rule. The second rule is zero is a sig fig. Zero is a sig fig if between non-zero numbers. Let's say 304. Right. So here's three sig figs. Now, another rule is that if the leading zero, oh, I mean, yeah, sorry. So if there's a leading zero, then it's not sig fig. Then it's not sig fig. Okay, let's see how this works. So 4.004, here's four sig figs. But when I say 0.006, there's only one sig fig, right? Because leading zeros are not sig figs. Trailing zeros are also not sig figs. Trailing zeros are not sig figs. So trailing zeros are not. Sorry, my bad. Trailing zeros are sig figs after decimal. So let's say here's 4.04000. Now because there's a decimal, therefore I can say there's six sig figs. But if it was 40400, then there's only three sig figs. Because if there's a decimal, then only the leading zeros count as sig figs. And in this thing, where in exponential numerical value, so there's sig figs is the one which has the numerical part. So if it's 1.1.32 into 10 to the power minus 2, sig figs are 3. Look at this. If it's 3.21, if it's let's say 3.2 into 10 to the power 9. So here the number of sig figs are 2 because this numerical part right here is the one which contains sig figs. Okay, now let's solve this question, which is a dolly question. I'll be honest, like there's no way this is a question asked in JEE because I don't respect this question at all. But let's see. So, okay, the number of sig figs. So this is 4. So sig figs before a number do not count. Sig figs trailing zeros are significant. So leading zeros are not significant. So 0 is not. So 1. Oh, so this has 3. So if there's a decimal, then trailing zeros also count. So 10016 right here. Leading zeros do not count. Trailing zeros do count 5. So it's this, and this. So A2, yeah, this one. A2, B1, C4, and D3, right? Okay, now let's move on to this thing, which is error. So error is an important topic. There's three questions on error that I have brought for you guys. So error, let's see. Error. So this is important here. Many questions are asked on this. Just stay tuned and listen. So let T1, T2, T3, so on, up to Tn be times taken in total experiments. So if AMT, arithmetic mean of all the time taken, is T1 plus T2 up to Tn by n. So here this is the arithmetic mean and this is the true value right here. So T1 plus T2 plus Tn by n, which is number of experiments, number of times recorded while doing experiments. And delta T1, which is AMT minus T1, which is error in T1, error in measurement, because AMT is taken as the average value. Obviously, you guys agree that all these values will have different numbers in them because you're never accurate while measuring. AMT minus T2, delta 3 is this, and then so on up to delta t, and you guys can keep doing this. So this was our absolute error, which can be negative or positive, which is delta t. Now what is mean absolute error? So this was mean value. Now mean absolute error, which is delta t dash, which is delta t1 plus delta t2 up to delta tn divided by n. So this is the average error. So how we represent a value, the range of value is delta is amt plus minus delta t bar. So this right here is how we represent a range of an experiment. This is the range of where a value can lie, right? Okay, so now what is relative error or fractional error? Wait, let me explain. Okay, so whenever you have a value, an experiment's value, you're always given a range, which is amt, which is the mean of the values found plus minus the error, the max error or the minimum error in calculation. Okay, let's see. Let's see percentage error. Percentage error is fractional error into 100. Now let's look at fractional error. Fractional error is your AMT divided by, not AMT, the smaller one, which is delta T, which is the mean error, which is the error that is possible, divided by AMT into 100. This is my fractional error, this is my percentage error, equals to percentage error. A lot of times in questions they ask you to find percentage error. We'll even look at application questions right here, but keep this in mind. And yeah, and let's look at propagation of errors. So while adding or subtracting, you can just add a plus b and a minus b. So while adding, the errors get added, and even while subtracting, the errors get added, but the values get added, subtracted respectively, depending on what you're doing. Let's say if you're adding, the values get added. If you're subtracting, then the values get subtracted. But in both of the cases, whether it is subtracting or adding, uh, the errors, they get added. There's no subtraction of errors in any case. But in multiplication and division, the rules are pretty different. It's not about just adding or subtracting, it's about following a rule. So let's see what the rule is. So for errors in multiplication and division. Yeah, before that, let me tell you about minimum division of a device. It is the capability to measure in intervals. For example, clock, the minimum division is 1 second. That is, like, minimum division is basically the capability to measure in intervals. So for example, let's say a clock, right? Its minimum division is 1 second, which means it can only measure things in 1 second time intervals. It's not like it can say 1 minute and point 0.5 seconds. It can say 1 minute and 2 seconds, 3 seconds. So after every 1 second, you get an update of the new value. That is called minimum division. If reported mean is, let's say, yeah, so here's one thing. So if, let's say, the minimum division of a clock is 1 second, right? This is the data, keep this in mind. Then let's say the reported mean is 92 plus minus 1.5 seconds, which is practically impossible. You guys agree, right? In a clock, if you're trying to, measure the reported mean of the clock at that given time, it is impossible to have 92 plus minus 1.5 because the minimum division of a clock is of 1 second. It cannot report a value with zero point 0.5 of a second. So this has to be rounded off. And using our rounded off rules, we can say that this is going to become 2 because number right here is odd. And when it's an odd number, it goes to the next number, which is even. So right here, it's 92 plus minus 1. So, sorry, 92 plus minus 2 seconds is our reported mean. Reported mean. Okay, so this was the rule about minimum division. Now let's look at multiplication and division of errors. So let's say there's a plus minus delta a and b plus minus delta b are two numbers, and let's say there's a value x, so which is a times b. So if x equals a times b, let's find the range for x. Range of x is, so x equals a times b, and delta x equals, now here is the rule. It's not about just doing a times b. The rule is to do delta x by x. Let's say the range of x is del x plus minus delta x. Then delta x by x equals delta a by a plus delta b by b. This is the rule. Follow this and you can solve any question on multiplication or division. Even if it's division, just do the same thing. And yeah, one more thing. If there's power, let's say x equals a square b cubed, then what you do is, yeah. So if it's this, let's say this, right? X equals a square b cubed by c square. So if it's x equals a square b cubed by c square, then what you do is you say delta x by x equals 2 times delta a by a plus 3 times delta b by b. Now plus the same way 2 times delta c by c. So the power gets multiplied to the delta a by a, b by b, c by c, depending on what power is in what number. Right? I hope it's clear. Now let's solve questions and let's get done with UND and let's move to Werner caliper in the next video. Right? Well, how are you guys like going right now? Because honestly, JEE is getting too complicated because most of the stuff in it is kind of difficult right now. And like the number of students is just increasing like unlinearly. It's like increasing like 3x, 4x that way. There's not even like a linear growth. Like if there's like 50,000 students increased, sometimes there's like four times more. Like it's like 2 lakh. So that's what I'm saying. And sometimes if there's a decrease, then the next year there's a big increase. But yeah, let's not talk about that. Now let's go here. So consider two physical quantities A and B related to each other as B minus x squared by AT, where E, x, and T have dimensions of energy, length, and time. Okay, not that complicated dimensions, but we can do it even if you're a newbie, right? So the dimensions of AB are. hmm Okay, so I think to solve this question, I'm gonna use our rules which we did before, which is E equals B minus x squared by AT. So ATE equals B minus x squared. So x squared has dimension of b, and x is, as you know, x is length. So if x is length, b is length square, and a right here is, so ate is length square. So a is length square by time into e, L square t minus 1, and energy equals work done equals force into displacement, which is m1 L2 t minus 2. So L2 is gone. T minus 2 becomes m minus 1 T1. So m minus 1 T1 into L2. So it becomes L2 m minus 1 and T1. So B is the right answer. Okay, let's move on to this one. There you go. A physical quantity P is given as this. Then the percentage error in the measurement of A, B, C, and D are 1%, 2%, 3%, 4% respectively. The percentage error in the measurement of quantity P is. So as I just explained to you guys, when you guys are given in powers or multiplication and division is happening, and the easiest way is to write down this way. Just watch. Delta P by P, which is the percentage error. So you have to find the percentage error. So as I told you guys, percentage error is delta P by P into 100. So delta P by P into 100 equals 2. Now because I multiplied by 100 on this side, 100 gets multiplied on every side, so it becomes delta P by P. Percentage error is 1, right? Percentage error of A is 1, means 2 into 1 plus, well, 100 can be cut because it doesn't matter. percentage error as long as yeah, so it's 2 into 1 plus 3 into 2 plus 3 plus 2. So this is 9 plus 11 plus 13. So it's 13%. And there you go. We've solved the question. And thanks for watching, guys. And see you guys in the next video. Keep watching the PSD series and keep learning.